You know, differentiation is not what you think it is. I've had some people commenting, differentiation is very difficult. It's just that hell of a chapter that you should have superpowers to do. Hey, I'm here to prove you wrong. Differentiation, come on now. Differentiation is just gradient at a point. Okay, Smith, why do you have this in your board? Are we studying gradient now? Is this a gradient video? No, it's not a gradient video. It's differentiation that falls under calculus. Okay, why are you writing gradient then? Because differentiation is just a fancy term of calculating gradient. That's what it is. That's what it is. It's just gradient at a point. Hello and welcome. So, by doing differentiation, you are doing gradient at a point, at any given point. That's what is differential calculus. Okay, so if you remember from grade 10, I don't know from grade what, but you were given that m is equal to y2 minus y1 over x2 minus x1. Well, as you grew up, you were told that this means change in y and this meant change in x, right? We are still talking about the same thing here. If you are given an equation, maybe let's just say we are given this. We are given mx plus c, okay? This is an equation and the subject of the formula there is y. But you wouldn't get y if it wasn't for x, right? So every change in x will cause a change in y. So if now you're trying to assess the change in y for every change in x, you'll get what? I'm telling you, you'll get gradient. But you'll see how. I hope you remember that a power. Let's talk about a power. What is a power? A power is a term where we have a coefficient, we've got x, and we've got an exponent. That's what is a power. Okay, then how do you do this differentiation thingies, BC? You take your exponent and multiply it to the coefficient, and then after that you subtract 1 from the exponent. I repeat, exponent multiplied by the coefficient and then exponent minus 1. Okay, let's do it right here. So we've got n times a. What are we getting out of that? We are getting an. Okay, and then we take our x back. What are we getting from n minus 1? We're getting n minus 1. Hey, it doesn't make sense. Just do another example. Okay, it's fine. What if we have 2x to the power 4? 2 is a coefficient, x is our base, and 4 is our exponent. Alright, now let's do it. 4 multiplied by 2 is going to be 8. X is just loyal. You'll see some cases where x is not loyal, but here it's just loyal. And then 4 minus 1 is going to be 3. SBC, are we done? Yes, this is the answer. You've just performed differentiation. What we call this, it's a gradient at a point. These people. Okay, let's do another one. What if we have 5x to the power 6? They say differentiate this. Okay, let me just say you are given y is equal to 5x to the power 6. Do you see that for every change in x, there will be a change in y? Right? So, if I want to differentiate, I'll say, what is the change in y for every change in x? If you know what I mean. What is this? As you can see, it's dy over dx. It means change in y over change in x. y2 minus y1 over x2 minus x1. Remember what this is. It's gradient. Alright, so we have 6 multiplied by 5. That should be 30. 30x to the power what? To the power 5. You know what I've just done there. So it's gonna be 6 minus 1. Alright, let me share this information with you. If you have an equation, I repeat, an equation where y is the subject of the formula, when you differentiate, you say dy over dx. That is what will give you a gradient at a point. And then, if you are given an equation again, I hope you know that f at x is also y, function of x. So, if you are given f at x, what is your derivative? Your differentiation should look like f prime x. Okay? But if you are given just an expression, if there is an expression that you should actually derive, they'll give you something like d and a small x, a capital letter D and a small x. That means it's no longer an equation. It's an expression, right? This is how you just derive. You don't write any fancy stuff, you just go straight to the answer. Okay, copy this down, please. And then, just do an example. I'm tired of you guys treating derivative and calculus as a whole like it's God from heaven. Come on now. So we are given this. They say, find f prime x if f at x is equal to 4x cubed minus 5x squared. Lovely. What is f prime x? Oh, f prime x, that is your derivative or differentiation. See, now we are given this in this form. That's why we are finding this, because we are given f at x. Okay, if we derive f at x, we get f prime x. Let's derive. It's gonna be 3 times 4, that is 12. You take your x back, and then it's gonna be 3 minus 1. Remember that n minus 1. So it's gonna be 2. I hope you understand. We have negative 5 multiplied by 2. Right? So it's gonna be negative 10. And then we take our x back. What is 2 minus 1? It's gonna be 1. I just hope you don't have, you're not brave enough to write that 1. So we don't write it. You should be very brave to write 1 as an exponent. So this is the answer. Oh, are we done? Yes, that is the answer. Okay, so let's do another one real quickly. What if you have y is equal to 2 to the power, 2x to the power 4 minus 7x cubed. Another one. How do you do this one? Remember now we've got this one in a form of y is equal to something. So our differentiation there, our derivative will be in a form of dy over dx. Do you understand? So let's do it. First term, we've got 4 times 2 and 4 minus 1. So we've got 8x to the power 3. Take your time and let that one sink. Why did I get 8 and 3? Because I said 4 times 2, I got 8. I said 4 minus 1, I got 3. See how it happens? It's very easy. So now I've got 7 times, negative 7 times 3. What is negative 7 times 3? It's going to be negative 21. And then what is 3 minus 1? Hey, spoiler alert. Okay, now you know it's going to be 2. Are we done? Yes, we are done. So stop treating differentiation like it's not even God. It's devil of some sort. No. So if you are new to this channel, consider subscribing because there is so much more coming on. So please subscribe. Why are you still not subscribing? Subscribe and hit the bell so that every time if I upload a video, a useful video like this, you get notified. Alright, so consider subscribing, liking the video. Tell me what you want to see next in the comments. Thank you for watching.